Okay, today we're going to talk about 8.5, which is the law of sines. And if you've noticed, everything that we've done up until this point has been with right triangles. And so this is a way that we can find missing sides and lengths of triangles that are not necessarily right triangles. So the law of sines states that um, what we have is the sine of angle A over the side length of angle A, and the sine of angle B over the side length angle B, and the sine of angle C and the side length C are all proportional to each other. So that's basically what we are going to prove, and this is how it works, or why it works. So if somebody were to ask you to prove that this works, or to show that this works, or perhaps to derive this particular example, these might be some words that they might use to ask you to explain the situation. And the way we do that is, first we would drop this altitude down here and call it h, but of course the variable for altitude is h. And from this we would try to find the sine of angle A and angle B using these two right triangles that we've now created. So we first start by saying the sine of A is equal to the opposite over hypotenuse, and the opposite side being h and the hypotenuse being b. Next we would say that the sine of B is equal to, again, the opposite, which is h, over A, which is its hypotenuse. Okay. The next thing I would do is I'm going to go ahead and solve each of these equations for h. So to do this, I'm going to multiply both sides by b. So I'm going to have the sine of a, and I'm going to have to put that in parentheses and keep it together, times b equals h. And then I'm going to multiply both sides by a in this particular situation, and I'm going to say that the sine of b, again, group it together, times a equals h. And now I have these two both equal to h, and because of that, I can use substitution and equal them to each other. So I have the sine of a times b is going to equal the sine of b times a. Okay, at this point, I'm going to just take a little sidebar over here, and I want to remind you guys of just how this proportional relationship works. If you remember, we had A over B equals C over D. We cross multiplied and ended up with A times D equals B times C. So if you notice, that's kind of the situation that we're in right here. So I'm going to not cross multiply, but divide each side and then get back to that proportional relationship. So I'm going to divide by A, which is going to take my A over here, and then I'm going to divide by B, which is going to move my B over here. And so in the last step, we will have that the sine of A over A is indeed equal to the sine of B over B. And that basically allows us to prove or show or derive this particular proportional relationship using the right triangular relationship that we already knew. Okay, so that's what we would put down if that particular question were asked. Um, Now let's try to use this particular proportion, the law of sines, and solve some problems. So in this particular problem, you have the angle A is equal to 48 degrees, and then you have angle B is equal to 93 degrees. I can go ahead and fill in angle C because I know that angle C is going to be equal to 180 minus 48 minus 93, right? Which will make angle C 39. So we'll go ahead and write that in just in case I need that later on. Okay, the other thing I like to do is to go ahead and label my sides by angle. So if this is angle A, then this makes that side A. If this is angle B, that makes that side B. And if this is angle C, this makes that side C. And that helps me keep my proportional relationships straight. So given angle A and B and looking for side A, I'm going to use A and B as my relationship. So I'm going to say that the sine of A over side A equals the sine of B over side B. And then I'll go ahead and fill in that information. So sine of, and A of course is 48 degrees, okay, over A, because that is the missing side that I'm looking for. And then the sine of B, which is 93, over 15, because that is the side length for B. At this point, I would just cross multiply. And I'm going to end up with the sine of 93 times A equals the sine of 48 times 15. Okay? And then finally, I'm going to divide both sides by the sine of 93. Okay? And that allows me to isolate A by itself. So I'll write A equals the sine of 48 times 15 over the sine of 93. Okay? And then once I plug that into my calculator, I will find out that side length A is approximately equal to, or about equal to, 11.2, rounding to the nearest tenth as we were asked to do. Okay? Okay, so the next thing I would do is look in the same triangle. I've just kind of clipped it and moved it down a little bit so we could have more room. I want to find out what the length of AB is, and that is actually side C. So I can actually use either of the ratios for this one. So I can say the sine of A over A equals the sine of C over C, or I can say the sine of B over B equals the sine of C over C. Okay? Now, the only reason one of these equations would be better than the other would be whether or not you're using a calculated value, as we would be in this first equation, right? A is actually a calculated value, and or a given value, which is actually what we would use here, is a given value. It's always a better idea to use a given value in case there's any mistakes that you made in the first value, although theoretically either of them would work. So I'm going to use this second one right here simply because it has a given value instead of 11.2, which is not only a calculated value but also a rounded value. So I will say that the sine of B, which is actually 93, okay, over B, which is 15, equals the sine of C, which we've just told you earlier was 39, over C, which is the missing side. I'll cross multiply and I'll get the sine of 93 times C equals the sine of 39 times 15. Okay? I'm going to divide both sides by the sine of 93. And I will have C equals the sine of 39 times 15 over the sine of 93. So we'll take just a second to punch that into the calculator. Okay, and that gives us 9.5 roughly, rounding to the nearest tenth. So C is going to be equal to 9.5 units. Okay, we can also use the law of sines to find the missing angles, and we'll do that in this particular one. We have been given angle R, and we're looking for angle S. So I will say that the sine of R over its opposite side, which is ST, equals the sine of S over its opposite side, which is RT. And then we'll fill that in with the actual value. So sine of R is the sine of 120 over ST, which is 18. And the sine of S, of course, is what we're looking for. And RT is actually 11. So go ahead and cross multiply those, and I'll say that the sine of 120, right, times 11 equals 18 times the sine of S. Okay? I'm going to divide both of my sides by 18. And I will see that the sine of S is actually equal to the sine of 120 times 11 divided by 18. And if you remember, when we're looking for a missing side, we will use the inverse sine. So in my calculator, I will say the inverse sine of sine 120 times 11 over 18. And when you plug that in, it looks like you get about 32 degrees for that one. Okay, so for this one, for number 2, we have KLM, and I'm going to go ahead and draw the triangle and then label its points so that I can try to get a picture of what's going on. And when I do that, I'm going to label them in the order in which they are listed so that I can make sure everything is going to be set up correctly. And it looks like that side KM is going to be 9, and side KM is going to be 14, and side LM is going to be 9. Okay, and then it looks like angle L is 105, and angle K is what we're going to be looking for. So I will set up my ratio proportion as the sine of 105, which is L, over 14 is going to equal the sine of K over 9. And then we're going to cross multiply. So I'll get sine 105 times 9 equals 14 times the sine of K. Okay? And then divide by 14. And it looks like the sine of K will equal the sine of 105 times 9 and then divide it by 14. Okay, and just like before, since we're looking for an angle, we're going to use the inverse sine. So in the calculator, I will say inverse sine of, and then I will punch sine of 105, right, times 9, all divided by 14. Okay, so let's punch that in and see what we get. Okay, it looks like once I plug that in, I will get 38.4. So that's about 38.4 degrees for angle K. So the measure of angle K is equal to 38.4 degrees. Okay, so we're going to use the law of sines to solve this problem. A ship has been at sea longer than expected and has only enough fuel to safely sail another 42 miles. Port City Lighthouse and Cove Town Lighthouse are located 40 miles apart along the coast. At sea, the captain cannot determine the distance by observation. The triangle formed by the lighthouses and the ship is shown. Can the ship sail safely to either lighthouse? Okay, so in order to find this out, we've got to use a little bit of trigonometry. So the first thing I want to find out is what this missing angle is right here at the ship. So I'll say 180 minus 70 minus 52, and that will leave me with 58 degrees. So I'm going to put 58 degrees. So I'm going to fill in as much missing information as I can right off the bat. So I'm going to say that the sine of 58 degrees, right, over 40 is going to be equal to, and I'm just going to go ahead and label these X and Y so that I have something to hang on to as I'm setting these up. The sine of 52 degrees over X, which is going to be equal to the sine of 70 degrees over Y. And of course, we'll have to solve these one at a time. So the first one I'll do is the sine of 58 degrees over 40 equals the sine of 52 degrees over X. I'm going to go ahead and cross multiply, and I'll get 40 times the sine of 52 degrees equals the sine of 58 degrees times X. Okay, so go ahead and divide by sine of 58 on both sides, and I will get x is equal to 40 times the sine of 52 over the sine of 58. And then I'll go ahead and punch that in my calculator and get an approximation for that value. Okay, it looks like the length for x is about 37.2 miles. So I will go up here and say, all right, so from the ship to the Port City Lighthouse looks like it is about 37.2 miles based on our calculations. And then I'll come over here and actually do the next one. So I'll say that the sine of 58 over 40, again, going back to given values whenever possible, equals the sine of 70 over y. And again, I'll just cross multiply these to see what I end up with. And it looks like I'm going to have the sine of 58 times y equals 40 times the sine of 70. And I'll divide both sides by the sine of 58. And I will get the value y is equal to 40 times the sine of 70 over the sine of 58. So we'll go ahead and fill that in and see what the approximate value is in my calculator. Okay, so once we do that, punch it in the calculator, I got 44.3, roughly 44.3. So that means that the distance from the ship to Covetown is about 44.3 miles, making it just a little bit further. So it looks like the answer to that question is no, that the ship does need to travel to Port City Lighthouse. That's going to be the best bet for that one. Okay, and got it. Number 3, we are looking for the distance for the right fielder to throw from here, where they fielded the ball between first and second, to second base. So we're just going to call this x because that's the value we're looking for right here. And I'm going to need, since I only have this 60 feet right here, I'm going to need to find this angle in order to use this as part of the proportion. So I will say 180 minus 68 minus 40, and that's going to give me the value for that third angle. So we'll say minus 68 minus 40, and that particular angle is going to be 72. So that makes this angle right here 72 degrees. So I can say that the sine of 72 degrees is proportional to 60 feet, right? As, and I'm looking for x over here, so I'm going to say the sine of 40 is to x. We'll go ahead and cross multiply, and the sine of 72 times x is going to equal the sine of 40 times 60. I will divide both sides again to get x by itself. And we're trying to isolate the variable so that we can get a numeric equivalent or a numeric value. So plug this in the calculator. So x will equal the sine of 40 times 60 feet divided by the sine of 72. Plugging that in the calculator, it looks like we get an approximate value of 40.6 feet, rounded to the nearest tenth. Okay, so the next page in the slides is actually the practice problems. I am going to check these on Friday instead of tomorrow because we have projects to work on tomorrow. So go ahead and work on the practice problems. Remember, you need to finish about 80% of it in order to get completion credit. Answers will be on the following slide. Please check your answers and let me know if you have any questions. We'll kind of go through these throughout the class periods the next couple of days as we work on our project as well. Okay, remember, due Friday. Okay, so this will go on the next 9 weeks, but make sure you don't forget because we're doing the notes ahead of time. Okay.